Good afternoon, ladies and gentlemen. My name is Business Ronaldo. I'm here to present to a short presentation about house pricing. I'll be using the data from Kabul, actually in predicting this. Now, I'll be using regression technique to actually find some house prediction. The problem statement. Now, when looking into the data set I see that actually I found that I have 13 explanatory variables which describe their property, or rather the independent variables. And the dependent variable now is going to be their house pricing itself. Now, when getting the data, the first thing that I needed to do was the pre-processing. Pre-processing actually consists of now loading the data set, yes, viewing, cleaning the data set, or exploring the data set. Now, exploring the data set, actually, it means now you have to check out some missing values, some outliers, or if your data set actually it is normally distributed. Now, in this case, I had two data sets, which is now the trained data set as well as the test data set. Then I have combined the two. And then I check the missing values. When looking into this graph, actually, the higher the bar, it shows now the higher the level of missing values or null values. Now, I needed them to actually deal with the null values. Now, normally, null values, especially in the data set, it is now shown as NaN, the NaN. But now, in this case, I'm going to put NA. Now, this data set actually consists of the categorical data set as well as the numerical data set. Now, in the categorical data set, I'm going to use actually the model class. I'm going to actually replace the missing values with the model class. And then in the numerical data set, I'm going to use the median or the mean. I'm going to choose between the two. But then choosing these two, it also relies on the results that I'll get from the model. Now, when checking this, actually, I see that actually in the bedroom distribution, now there is a missing value, but now the important thing, this graph here is actually showing the distribution. Is it normally distributed or not? Now, this is not, it's not normally distributed. For it to be normally distributed, actually, it should have been centered at 0, or it should not be skewed either to the left or to the right. Now, let's check on some actually cleaning data. Mind you, when collecting data, some features do not really contribute in the pricing, or do not have that much effect on the target variable. For example, in this case, we had a column which consists of the URL. Now, the URL cannot actually help us in predicting the house, so I have to remove it. And then, now also I went on and in checking if now some of these actually independent variables, are they correlated to each other? This is of course this is one of the assumptions of linear regression. Now, in this graph here, or in this table here, actually, I'm checking on their correlation. Now, the darker the light, the more they are correlated. And the lighter it is, it means now they are not that correlated. Now, that is now removing the collinearity. But now, I've used then, again, a certain function which will simplify what we see on the screen. Now, on this function, actually, I was only taking now these variables which are 70% and above correlated. Now, this is what I got. I got the bedroom as well as the bathroom. Then, with this, I then needed to remove one of them. And now, removing this one, now it means now I removed the bedroom there because now it has too much missing values. Then it was going to mislead me at the end. Then I stayed with the bathroom. Now, continuing with the pre-processing. Now, in here, actually, on the categorical data, we had to encode we had to encode the data set that's dealing with them in dummy variables. And then now the models of interest, that's linear regression, the ridge as well as the lasso. Then I did all of this one by one to check actually the distribution. And in this case, now I found that lasso with that, we are actually looking at the root mean squared error. Then went back to normalize my data, and then after normalizing my data, I then went back to test my final results, my data again. And then when I do that, after normalizing the data then, these are the results which actually comes out. With this result then, I can then make a conclusion and take the linear regression as my final model. Reason being, it has the lowest root mean squared error, which then help us in actually concluding. And now we had some shortcomings, and nevertheless, which we actually dealt with. Shortcomings would include the outliers. Thank you.